And welcome to lesson 3.3. Last lesson we talked about what a logarithmic function was and we graphed them. We got a lot of the basics of that in. Now we're going to look at properties of logarithms. What you'll find, well, let's look at the objectives. So we're going to talk about product rule, quotient rule, power rule. Last lesson we talked about how logarithms are exponents, just in a different direction, right? It's looking at exponents in a different way. The product rule, quotient rule, and power rule for logs all mirror those rules for exponents. And that's how we'll go through them when we look at them. Then we're also going to use those rules to expand and condense log expressions. And then finally, we'll talk about a change of base property. And that will bring into play the common log and the natural log that we talked about last lesson. The first rule we're going to talk about is the product rule. So let B, M, and N be positive real numbers, and B can't be 1, because then it wouldn't be a log function at all. When you have multiplication of a log inside, so what you're taking the log of, M times N, right? You can also rewrite that as log base B of M plus log base B of N. The logarithmic product of a product is the sum of the logs. So how does that make sense if you know the rule of exponents? Well, the rule of exponents is when you have like bases that you're multiplying, you add the exponents, right? So in the exponent rule, the multiplication was linked by the addition of the exponents. In this case, the multiplication of what you're taking the log of is linked by addition. So multiplication and addition are linked in that way. We'll look at a couple quick examples here. Part B is probably more appropriate here for this rule. So 8 and 4 are rewritten as 2 cubed and 2 squared. Since they are the same base, that's why it goes 3 plus 2 is equal to 5. But you're adding those exponents together, okay? And then the last one here, that multiplication on the inside, 8 times 4 becomes 8 plus 4 on the outside. So use the product rule to expand each logarithmic expression. So it probably seem a little simpler than those examples that were on the last page. Say what, I'm going to do the first one, then I'm going to pause it and let you try part B. So log base 6 of 7 times 11 is simply equal to log base 6 of 7. Remember, multiplication on the inside linked by addition on the outside. So then log base 6 of 11. That's it. All right, you break it apart. You break apart what's happening in here into the two parts here and here, and it's addition that you're looking for when it's multiplication. So take a minute. I'm going to pause, take a minute, try to write that one out, and then we'll compare. So it just becomes natural log of 100 plus natural log of x. Remember that, or maybe not remember, note that this rule is applied no differently when we're talking about a natural log compared to log of base anything, right? So this rule is the same. Natural log, remember, is just a fancy way of saying log base e. So again, it's no different. It's just is a different notation to mean something that is the same. It's just a different base. And it gets applied the same way. All right, so let's take a look at the next rule, quotient rule. Well, multiplication was linked through by addition, right? So if there's division inside the log, it becomes subtraction on the outside. And again, that's the same thing with the exponent rule for dividing. If you have two bases with exponents, two like bases with exponents, and you divide one by the other, you subtract the exponents. Same thing. We're linking division here with subtraction here. Really look at example C here. You have 32 divided by 2. That gets broken into log with the same base, log base 2, and it's 32 and 2 are split, and subtractions in between. These are already done for you. I guess there's no point in me pausing it and having you try one, but let's talk them through, right? Log base 8 of 23 divided by x is equal to log base 8 of 23 minus log base 8 of x. Division on the inside is subtraction on the outside. Bases are the same. You just split them up. Okay. This one looks a little more complicated, at least with the answer, but it's not. So first step is what we just talked about. Natural log of e to the fifth divided by 11, you just split it up. E to the fifth, natural log of e to the fifth, natural log of 11, and it's subtraction. What happened here is actually something we talked about last lesson. When the base is the same as what you're taking the log of, then it just is equal to whatever the exponent is. So remember, natural log is base e, so essentially that cancels out to just be 5. So that's what's happening from here to here. But the quotient rule that we just talked about is how you get to this line here. All right, power rule. So log base b of m raised to the p. So really there should be parentheses here. I guess actually you don't need it because technically, because that would be implied that that exponent is part of the m. You would need to have parentheses around the entire statement if the exponent was on the whole thing. Anyway, what happens is an exponent on the inside becomes multiplication on the outside. Again, think of the power rule for exponents. This is where you're raising an exponent, like let's say you have x to the third in parentheses and then squared, right? When you simplify that statement, it's not x to the fifth. It's not 3 plus 2. It's x to the sixth. It's 3 times 2. So exponents are linked through the exponent rule by multiplication. Same thing here. A power on the inside is a multiplication on the outside. All right. And the best example down here that you can see is part C. You have 9 squared, okay, on the inside. That 2 becomes multiplication on the outside. Again, these are already done, so let's just talk them through. You will have several examples to try in a moment, so I think that's okay. Again, log base 6 of 3 to the ninth, that 9, that's an exponent on the inside, becomes multiplication on the outside. There's an extra step here because it's natural log of the cube root of x. First thing we're going to do is turn that cube root statement into an exponential statement, meaning it's the exponent's 1/3 on the x, right? That's equivalent. That allows you to use the power rule because now that 1/3 is an exponent. So that 1/3 that's an exponent on the inside becomes multiplication on the outside. So just an extra step there. Notice how here you have the x plus 4 squared. So then the x plus 4 stays. That 2 becomes 2 as multiplication on the outside. All right, so properties for expanding logarithmic expressions. So this is just a summary of everything we just talked about. Product rule, multiplication inside, addition outside. Quotient rule, division inside, subtraction outside. Power rule, exponent inside, multiplication outside. So you're going to use those rules in combination to handle something like this, where you're just given logarithmic expressions and you're told to expand them. So you're going to use properties, maybe more than one, okay, at a time, to expand them and expand them as much as possible. So, well, I'll tell you what, let's do example A, and then I'll leave the other ones for you to try, and then we'll come back and go over the answers. So how do you know when to stop? Well, how about we start one first? First thing I'm noticing is there's multiplication here. It's x squared times square root of y. So I'm going to split that up based on the product rule. Base stays the same when you split it. So even for this part here, it's got the same base b. Also, I'm going to do the step that we just talked about, where square root of y, I'm going to write instead as a rational exponent. So square root is 1/2, just like the cube root was 1/3, right? Now I'm going to use, so this was product. Now I'm going to use the power rule, and I can use it on both sides. but you're only using it for each side separately, if that makes sense. So the power rule here, you have an exponent of 2, so that 2 is going to pop out front to your multiplication. So it'll be 2 log base b of x. And then here you have an exponent of 1/2. So using the power rule, that 1/2 will pop out front. And it'll be 1/2 log base, not lob, shoot, log base b of y. Okay, we are done. And how do you know you were done? Again, this is the power property. If we were labeling them, how do you know you're done? When you're done when there's nothing left to do. So that's a I'm not trying to be any kind of tone with that. That's how you know you're done, right? There's no, if there's no other rule that you can apply, that means there's no other rule that you're going to apply. So some you'll apply one rule. This one we applied 2. You could even apply all 3 rules potentially. I think part C looks like an example where you might apply all 3 rules. Okay. So yeah, give these a try. I'm going to pause it now. I want you to try all of them, and I'll come back and we'll go over the answers. All right, part B. First broke it up using the product property. This is part B is almost exactly like part A. Broke it up with the product property, and then use the power property to get the exponent of 4 out in front of log base b of x, and then the 1/3. Again, I also turned the cube root into 1/3 there. Then use power property to get the 1/3 out in front of log base b of y. All right, part C. I think C is honestly the hardest one on here. And I probably do this step a little different than you might have thought. So consider that when you use the quotient property here, 25 and the y cubed are both getting divided in the original expression, right? So they both need to be subtracting when you split them up. Even though that is multiplication there, think about it like there's parentheses because the fraction works as a grouping symbol there. So both the 25 and the y cubed, when you split them, even though they're multiplying in the denominator, they're in the denominator. So they both need to be subtracted. And I split them all up in one step. If you did it in 2 steps, that's fine. Just understand that, consider that they're both in the denominator, so they both need to be subtracted because they are both part of the denominator in the original fraction. Once I have them split up with subtraction using the quotient property, I then use the power property. So the 1/2 that's the exponent here becomes the product out front, right? Or the multiplying out front. This part you might not have considered, but when it says simplify as much as possible, right, or expand as much as possible, log base 5 of 25 is an expression that can be simplified. Log base 5 of 25 when evaluated is 2, right? Because 2 is the exponent you put on 5, you get 25. So if that comes up, make sure that you're handling that in that way. And then using the power property here, that 3 becomes the coefficient there. All right, part D, I used product property first to split up x times square root of x squared plus 1. So that's why there's addition there with them split up. I turned the square root into exponent of 1/2. Now that 1/2 becomes the coefficient there. You can't use the power property on the x squared plus 1 because that was combined with the plus 1 under the square root. So you're not using the power property there. That would need to be separate. You can't split that up with any property because it's addition on the inside. Remember, you can only use the product property when it's multiplication on the inside. That becomes addition on the outside. You can't split that up. Part E, first thing I did was quotient property, turned that division on the inside into subtraction on the outside. Then I used power property to take care of that 2 and that 3. Again, the x minus 1 has got to stay x minus 1 in parentheses. Last part, part F. All right. There was product and quotient property that I did together in the first step. So the x squared, all right, why can't you see my screen? Go back. All right. Okay. There you go. Now you can see where I'm pointing. The multiplication in the numerator split up with addition on the outside. So x cubed square root of x squared plus 1, I put in parentheses and gave it an exponent of 1/2. Then the denominator, I subtracted now on the outside. Then I use power property. So the exponent of 3 comes out front as 3. The exponent of 1/2 comes out in front as 1/2 in this part. I ran out of room here, but the exponent of 4 becomes an exponent of, or a coefficient of 4 there. All right. Let's move on. Next part of the objective is condensing. So we use those rules to take a condensed expression and expand it out as far as possible. This is the exact opposite. You're going to be given multiple logs, and you're going to use the rules that we just talked about to go the other direction. We're going to put them back together, essentially. So these properties, these rules, are the same rules that we learned, just the other direction, right? So addition on the outside becomes multiplication on the inside. Subtraction on the outside becomes division on the inside. Multiplication on the outside becomes an exponent on the inside. So we're just applying, again, these same rules the other direction. So got 4 examples here. Let's do them. All right. So if the base is the same, and by the way, this only works when the bases are the same, right? So these are both common logs. So they are the same base. Again, addition on the outside is multiplication on the inside. So this is equal to log of 25 times 4. So you could go ahead and say it's log of 100. If you wanted to get really technical, common log is base 10, right? So this could get evaluated because the exponent you put on 10 to get 100 is 2. All right. For this one, common log, so they both have the same base. So you can use now the quotient property. So this would condense into log of 7x plus 6 divided by x. Can't do anything else with that, right? It looks tempting to maybe divide those x's, but you can't because there's no x on the 6, right? So that's it. Let's change the color so we can keep it separate. Next one gets a little more complicated, right? What I would do first is, well, if you think back to when we were doing all the expanding, we would do a product or a quotient rule first and then a power rule, right? That just kind of flowed and made the most sense to do it that way. When we're going in reverse, it kind of makes sense to do it opposite. It makes sense to do the power rule first and then the product or the quotient rule. So the first thing I'm going to do is take care of this exponent of 2. Well, it's a coefficient of 2, which will become an exponent. So it's natural log of x squared. And then here, the exponent of 1/3 will be, I'm sorry, the coefficient of 1/3 will become an exponent. Didn't mean to make that an equal sign. All right, so we got plus natural log of x plus 5 raised to the power of 1/3. Now I can combine them using the product rule. So it'll be natural log of x squared times, and technically, I guess it's considered more condensed if you don't leave it as an exponent of 1/3. Personally, I don't care as much, but when you get into Math Excel, they might prefer you to write this like this. Right, so instead of leaving it as an exponent of 1/3, actually make it a radical of, in this case, a cube root. All right, why don't you pause and try the last one? I know there's 3 parts to it, but give it a try and then come back and I will go over the answer. So the first thing I did again was use the power rule, right? So that 3 became an exponent of 3. Oh, you know what? I didn't do it right. I'm going to pause. See if you can figure out my mistake, and then I'm going to pause and fix it, and then I'm going to be back in a second. Okay, that's better. So my first step was fine, just using the power rule. But then the mistake I made was I was treating those subtraction signs like addition signs, and that's why I had everything multiplied. But since these two are getting subtracted, they are both going in the denominator. Um, so you have x cubed, natural log of x cubed in the numerator, and then the denominator, it's y plus 1 squared times z to the 1/2 then became square root of z. And that's in the denominator, again, because they're both getting subtracted. Okay? All right, let's take a look at the next one. Let's erase that first. All right. I think second to last part, or maybe last part of the objective, actually. Yeah, this is the last part. Is change the base property. So you have just a regular generic log statement expression, log base b of m. Okay, you can rewrite it as log base a, so a new base of the m divided by log base a of b, which was the original base. Why would you want to do that? Well, you'll see on the next slide examples specifically, but the reason why you would want to do that is to convert it into most likely either a common log or a natural log because they're just easier to work with. And also depending on what kind of calculator you have, easier to evaluate. Because it works out nice when if I give you something like, oh, what's log base 3 of 9, right? Well, that works out perfectly because the exponent you put on 2, I'm sorry, the exponent you put on 3 to get 9 is 2. But what if I said, what's log base 3 of 8, right? That's not an integer. That would actually be something you would have to calculate based on, using a calculator, essentially, right? Because you're not going to get an exact answer. So, I mean, I guess you could do it by hand, but that would be pain. But anyway, um, you know, most things are not going to work out perfectly. Most numbers are not perfect squares. So, or more numbers than not are not perfect squares. So that's why you would want to use this thing. So here you go. If you have log base b of m, so that generic example again, and I wanted to convert it to a common log, I could just say that's log of m divided by log of b. So again, that's a way you can evaluate on a calculator that doesn't have the ability, which if you have a brand new or relatively new at this point, TI graphing calculator, you might have the ability to just type in whatever base you want. Well, guess what? That wasn't available on older calculators. So if you have an older TI like I do, um, I don't have that ability, so I would be using this change base property. Now, it does make sense that that's something that they added in. They probably should have added in 20 years ago. TI should have added that feature in 20 years ago, but they have not until some of the newer calculators that I've seen students have in the last couple of years. Um, so that is truly like one advantage that you might have if you have a newer calculator. But other than that, they pretty much do exactly the same. But that's like to me the biggest improvement that these calculators are made. I mean, some of them have color, whatever. Like it's nice, but it doesn't really, I think, change your answer at all, right? Or change your ability to get the correct answer at all. Um, some of them can plug in as opposed to using batteries. That's nice because you're not wasting money on batteries. But other than that, like this is the biggest innovation DI's made in the last 30 years of the calculator. Anyway, so that's a formula that might have been more important if you have an older calculator. And then also do the same thing with a natural log, right? So log base b of m is equal to natural log of m divided by natural log of b. So using common logs to evaluate. So again, if you're lucky and you have a calculator where you can type in base 7, awesome. You can just type it in that way. You don't necessarily need to use this theorem. Although when you get to Math Excel to do the practice, you might need to, do an example or a practice question where you have to show like what the change of base formula is. You need to know the formula. But if you have an older calculator, you can type it in this way separately. Log of 2,506 divided by log of 7. And either way, you're going to get that it's, if you're rounding to the nearest hundredth, 4.02. So that's it. I have an exit ticket made. we will, you know what, since you're already doing the lesson quiz today, we will do the exit ticket together tomorrow. So try to get these notes done before class. Well, I guess if you're to this point, you are done, so you don't need me to tell you that again. But you have these done by class time on Tuesday, and we will do the exit ticket together and start the practice. Let me know if you have any questions.